I'm Mimi, and today I'll be talking about 5 types of chemical reaction. So the first reaction is synthesis reaction or combination reaction. Okay, and the second one is decomposition reaction. The third one is single displacement reaction. Fourth one is double displacement reaction. And last one is combustion reaction. So the first reaction is synthesis reaction. In this reaction, 2 or more substances will combine to form a new compound. So here's a formula. A plus X produce AX. Okay, so at the reactant side, over here, when A and X are still alone, they are called simple substances. But then when it combines together to form AX, it will become complex substances. So in this reaction, simple substance will combine together to form a complex substance. So the second reaction is decomposition reaction. This reaction is totally opposite to the synthesis reaction. In this reaction, a single compound undergoes a reaction that produces 2 or more simpler substances. So here's the formula. AX, they're together, and then after that, it will form A plus X. So it means that these two, at first they are together and it is called the complex substance, but when it undergoes a reaction, it will form the simpler substance, which is A and X. Next reaction is single displacement reaction. In this reaction, one element replaces a similar element in a compound. It is also known as replacement reaction. In this reaction, there are 2 possible formulas. First one is A plus BX result in AX plus B. And another one is Y plus BX result in BY plus X. So in this reaction, the ability of A replacing B or Y replacing X is dependent on the activity series. So the fourth reaction is double displacement reaction. In this reaction, ions of 2 compounds exchange places in an aqueous solution to form 2 new compounds. So here's the formula. AX plus BY will produce AY plus BX. Okay, so as you can notice here that X and Y will be switching places. So at first A is with X and B is with Y. But then after that, A is with Y and B is with X instead. So this will occur when the cations combine with the anions to form an insoluble and slightly soluble compound. Okay, and the last reaction is combustion reaction. In this reaction, hydrocarbon combines with oxygen, releasing a large amount of energy in the form of light and heat. So the formula is hydrocarbon combine with oxygen to produce CO2 plus H2O. If you see that the product is CO2 plus H2O, that is normal because it is complete reaction. But then when you see that the product is only CO plus H2O, it means that it is incomplete reaction. Okay, so and now I'll be giving the examples of the 3 chemical reactions out of 5. First, decomposition. Second one is single displacement, and the last one is combustion. So let's start with decomposition reaction. For the example, this one I've chosen Al2O3 result in Al plus O2. So at first it's together, but then it breaks down. So as you can see that the number of both sides are different. For the reactant side, Al has 2, O has 3, but for the product side, Al has only 1 and O has only 2. So we have to make it balanced. Okay, so let's start. Over here, you can clearly see that Al are different. So for the reactant has 2, but the product has 1. So you put 2 over here. So now it will be equal. but it's not yet done because you can see that O at the reactant side has 3, but O on the product side has 2. So you have to balance it. I'll put 3 over 2, but it's not equal yet because it has to be the whole number only. So I times 2 to the whole equation. So now over here will be 2. Over here is like 2 times 2 before. And when 2 times 3 over 2, it will become 3. So now you can see that Al on the reactant has 4 and O has 6. And you can compare to the product side. Now you see that they're equal. Moving on to the next example, which is single displacement reaction. In this reaction, the example would be Zn plus HCl and result in ZnCl2 plus H2. So let's start balancing. Over here, you can see that the reactant side and the product side for Sn since is the same, so we don't need to do anything about it yet. And now, HCl, you can see that the number of H and Cl for the both sides are not yet equal because H and Cl on the reactant side has only 1, but the product side has 2. So we have to balance it. Now let's put 2 in front of HCl. Okay, so it's equal now because both sides has the same number. And according to the activity series, since it's more reactive than H, so it is able to replace H. Because as you can see, at first since it's alone, right? But after a reaction, it switches places with H. So now H is alone. Lastly, it is combustion reaction that I will be giving examples. So this one, C6H6 plus O2 result in CO2 plus H2O. So let's start balancing. Start with C. On the product side, C has only 1, but for the reactant side, C has 6. So let's put 6 here in front of CO2 first. Then you can also see that H hydrogen on the reactant side has 6, but for the product side has 2. So now let's try to make it 6. So 3 times 2 would be 6, so let's put 3 here. And now it's oxygen left that's not equal. On the product side has 12 plus 3 oxygen, so it means that there are 15 oxygen for the product side, but it has only 2 for the reactant side. So now we have to make it equal. Okay, so 15 over 2. Okay, the reason I put 15 over 2 here is that when I times 2 to the whole reaction, the number of O will be equal. So let's see how will it be equal. So now I'll have to put 2 here. After that, oxygen over here, 15 over 2 times 2 will be 15. And for the product side, 6 times 2 would be 12. Lastly, H2O is 3 times 2 becomes 6. Okay, now let's check if it's equal or not. So for the reactant side, there are 12C and also 12 hydrogen. And for O, there are 30. Okay, now let's check. For the reactant side, there are 12C. Okay, so it's equal. And for H, there are 12H. And lastly, O, there are 24 plus 6. So it is 30. They're now equal. Okay, and that's it. Hope you understand it. And thank you for watching. Bye bye.